This is the screencast for section 4.2, example 3. We're going to apply the mean value theorem. Let f of x equal the square root of 1 minus x squared, which you may or may not recognize as being a half circle, radius 1, center 0, 0. I kind of graphed it down here. A is the point -1, comma f of -1, and b is the point 1, comma f of 1. So, in other words, A is going to be -1, comma 0, and b is going to be 1, comma 0. Find a tangent to f on the interval -1 to 1 that is parallel to the secant AB. So you can tell we're looking to satisfy the mean value theorem and find a tangent whose slope is 0, because the slope of the line connecting A and B, or the secant connecting A and B, is going to be 0. So let's find the derivative of f prime first, or a derivative of f. And by making the square root a 1/2 power and using the chain rule, I get that the derivative of f of x is going to be -x all over the square root of 1 minus x squared. And that does tell me that x can't be +1 or -1, but those numbers weren't included in our interval anyway, so that's good. Instead, they stuck the points a and b there that we're supposed to be satisfying the slope to, so that's fine. So now I'm going to set that equation equal to the slope of 0 and solve. And I get that x equals 0, which you may have suspected. So this tangent line here has a slope of 0, and so does the secant line connecting A and B. So it says find a tangent to f in the interval -1, 1 that is parallel to the secant AB. The tangent here is going to be the horizontal line y equals 1. X equals 0 is a vertical line. That's the location of the point where this tangent is tangent, but the actual equation of the line is y equals 1. So now try problem. Exercise 9 says the interval a to b is given. Let a equal a comma f of a and b equal b comma f of b. Write an equation for the secant line AB. Okay, so the point A is going to be 0.5 comma 2.5. The point B is going to be 2 comma 2.5, which the y values are the same, so the line connecting those is just going to be y equals 2.5. The y coordinate has to equal 2.5. Now part B says find a tangent line to f in the interval AB that is parallel to AB. So to give you an idea, I drew the graph here, and then A is about here, B is about here. So we're trying to find, well, I guess this tangent down there and its equation. So let's find the derivative of f. So I'll set that derivative equal to 0, the desired slope where the tangent line, or to find the x value of that tangent line whose slope is 0. And I get that x can equal 1 or -1. However, -1 is not in our interval, so we're not going to use -1, we're just going to use +1. Well, again, x equals +1 is not the tangent line we're looking for. That's just the x coordinate. The y coordinate, if I plug it back into the original equation, is 2. So the horizontal line is y equals 2. That's the line that has the same slope as the secant connecting A and B, which just so happens to be a horizontal line of slope 0.